So what we are going to do today, tomorrow, is to look at some vectors. Now, we've already talked about vectors in here, okay? But we talked about them in 2 dimensions. Well, now we are in 3 dimensions, okay? So a lot of what we do today is remembering what we did in 2D and apply it to 3D. And then there's one brand new concept that we'll talk about at the end, okay? So, a vector. I will remind you that there are 2 different ways to write a vector. One is in component form, which is this right here. Since we're in 3 dimensions, we're going to have 3, an ordered triple, if you will. Okay, with the chevrons. Remember those chevrons? Okay, so -1, 2, 4. Okay, we're just going to plot that point. -1, 2, 1, 2, 3. There's that coordinate. And so our vector, remember we go from the origin to the coordinate. Okay, there's our vector. Octant number of that vector. 2. I really like octant 2 up here. Got a lot of octant 2. Okay. Now, remind me, if I have the vector PQ, where P is the point 1, 2, 3, and Q is the point -2, 0, 5, how do I calculate PQ? If I know where the vector starts and ends, that would be the length of the vector, because you're talking about distance. Well, I'm trying to find components. If I give you coordinates, you need to take the terminal point minus the initial point to get it in component form. Okay, so since our vector is PQ, I have to take -2 minus 1, 0 minus 2, 5 minus 3 to get it into component form. Remember that now? All right, now do you remember? Do you remember how we used those I's and J's? There were 2 different ways to write a vector. Okay, when we are in 3 dimensions, okay, there's going to be 3 standard unit vectors. So, what was the vector I in 2 dimensions? The vector 1, 0. The vector J, 0, 1. Well, now the vector I, since we're in 3 dimensions, is 1, 0, 0. Vector J is 0, 1, 0. And then we have vector K, 0, 0, 1. So there's standard unit vectors in each of the 3 directions that we have. Okay. And we got to put it under here. Alright. Okay, so two different ways to write a vector. 3, negative 5, 2 would be the same as 3I minus 5J plus 2K. Alright, I'm not going to worry about graphing this one. I think we've graphed enough points. I'm not as worried about graphing vectors. I want to get into all of the things we find with our vectors. Okay? So what was the definition of a vector? Remember vector? That guy that we watched? What did he say? Yeah.
Vector, or vector, not vector. Both direction and magnitude.
Okay, direction and magnitude. That's what makes a vector. Okay, a line segment with direction and magnitude. Let's first talk about magnitude. Okay, the magnitude of a vector. We talked about this a few months ago. Magnitude is essentially describing what of the vector? Size and what matter? The length. Okay. So if you recall, if we had a vector, v1, v2, how did we find the magnitude? I'll remind you that that's the notation for magnitude. Okay, so it's the Pythagorean theorem. Okay. The square root of horizontal component squared plus vertical component squared. Okay, so now when we step it up to 3 dimensions, how is it going to change? Magnitude is just going to be the same thing, except now we have a third dimension to consider. Calculate the magnitude of this vector, negative 1, 2, 2. Maverick, what's our magnitude?
3.
3? We have 1 plus 4 plus 4. Square root of 9 is 3. Do you agree? Okay. Another question you'll know you'll have on your test. Okay. Now, unfortunately, in 3 dimensions, we're not going to talk about the direction of a vector. In 2 dimensions, we can easily describe the direction from the angle from the x-axis. Okay? Well, in 3 dimensions, we have all sorts of angles that we can calculate. Okay? Those of you who go on to Calculus 3, you'll talk about how to find the different angles from each of the axes in free space. Not something that we're going to worry about in here. Okay? So we're just going to skip over direction, and we're going to go to operations with vectors. I just want to remind you on how to do this. What?
Is it called calculus CD?
No. Calc 1, Calc 2, Calc 3.
Do you have Calc 3 at the school, or is it too like high?
Be cool. Okay, so we have vector u and vector v, 1, -2, 3, 0, 5, -2. Describe to me. We need to subtract two vectors. How do we do that? Huh? Okay, so we need to subtract their corresponding components. So, or I guess the x component, 1 minus 0. The y component, -2 minus 5. The z component, 3 minus -2. Okay? At your pod together, please find me 5v plus 2u. Tegan, what do you get? Can you tell me how you get 2? Oh, never mind. I was looking at 5u plus 2v. Okay. Do you agree with Tegan? Okay. Excellent. Unit vector. This is something that trips people up a lot because they just don't remember how to get there. So I will remind you. First of all, what does a unit vector mean? Okay. A unit vector means we have magnitude of 1. If I give you a vector and I say find a unit vector in the same direction, that's when we take 1 over the magnitude and we multiply it by the vector. This is something that I asked you to do in 3 dimensions, but like I said, some of us had trouble remembering that rule. So, get it back into brain. So we've already talked about this vector. Vector v was -1, 2, 2. And we found its magnitude. What was the magnitude of -1, 2, 2? It was 3. Okay. So if we're talking about the same direction, if we multiply a vector by a scalar, we're still going in the same direction. We're just changing its length. So if we take this vector and multiply it by 1 over the magnitude, then we're forcing it to have a magnitude of 1.
No, I can't find my math page.
Okay. Dot product. We have this and then 2 more. if I gave you two vectors and I asked you for their dot product, did we have this on the final?
I don't think so, no.
No? It was on final, we didn't have vectors on the final?
Just add the,
What?
just add the.
We have, yeah. We take the product of the horizontal components and add it to the product of the vertical components. Okay? So when we move into 3 dimensions, we're going to do the same thing. But now, whoops, we're going to have 3 products to take. Okay, so when you're done writing down the notes that you need to write down, that is the example I would like you to do and check with your neighbor to see if they get the same answer. Okay, Jared, you agree with -1? Yes. Awesome. All right. 2 more things. Angle in between vectors. There is a formula for angle in between vectors. This is when you're going to need your calculator. Okay? So you may want to get that out. As we remember the formula for the angle in between 2 vectors. That look familiar? Well, I know it was for chapter, is that chapter 6? I'll look. I know that it is not printed on the test, so I'll talk to Ms. Cronkey about whether we're going to make you memorize it this time. Okay. Okay. So if I give you 2 vectors, okay. Now remember, this is always going to find us our quickest angle. Okay, there's obviously going to be a lot of different angles that we can calculate, but essentially what's going to happen is if we have 2 vectors, and we put them in standard position, we would be able to put a plane through them. Okay? So in that plane that we can slice through with the 2 vectors, we're going to find that angle that's in between the 2. Okay? So this does become a 2-dimensional problem. Okay? So the magnitude of u what would it be? Radical 5. Magnitude of V would be radical 10. And then, oh, and we need our dot product, right? U dot V would be 1 times 3 plus 0 times 1 plus 2 times 0. That's kind of boring, huh? So the cosine of theta is 3 over square root of 5 times the square root of 10. My advice to you when you're doing this in your calculator, I would press inverse cosine of 5 divided by, I would just call that the square root of 50. That way you don't have to worry about having a product in the denominator, okay? It's just less parentheses for you to type in. Okay? If you typed in square root of 5 times square root of 10, that would have to be in parentheses in the denominator because it is a product. $65. 64.9. Okay. What would it mean if our dot product is 0? What would happen down here? Okay, if our dot product is 0, that means this whole fraction is 0, and the cosine of theta equals 0 would mean that theta is 90 degrees. Okay, so remember we called that orthogonal. If the dot product is 0, we have orthogonal vectors. Okay, now, what would it mean if our angle was 0 or 180? What would it mean about the vectors? They're parallel. They're going either the same, 0 degrees, or opposite, 180 degrees. And so they're going to be parallel. Now, we already kind of talked about parallel vectors about 5-10 minutes ago. Okay, how can we tell that two vectors are parallel? If I have the vector 1, 2, 3, what would be a vector parallel to it?
You have to have like the same magnitude.
Not the same magnitude. The magnitude is going to change every time. But this is like our three-dimensional slope. So I can't remember if Caleb or Nick was asking me about slope. We can't actually calculate slope in 3 dimensions, but we can use vectors. Okay? Our vector 1, 2, 3, that's kind of describing its slope because we're talking about 3 different dimensions here. It would be in the same direction as 2, 4, 6. Or it would be in the same direction as -3, -6, -9. Okay, what's true about those vectors compared to 1, 2, 3?
Like just that vector multiplied by.
Okay, it's a vector multiplied by a scalar. Okay, if vectors are scalar multiples of each other, then they are parallel. Okay. Why am I making such a big deal of this? We can actually use the concept of parallel vectors to determine if we have collinear points. Okay? Go ahead and write down these 3 points. I want to determine if they are collinear. So what I would do is I would write down those 3 points and write collinear question mark in your notes. we're doing a cake lab next hour. I'm gonna bring my cake stand to figure out how much volume is actually in it. No, but he's using my cake stand. No. Okay. I have 3 points. We're going to use vectors to determine if they are collinear. How would we do that? Okay. We can create a number of vectors out of these 3 points, but we only need to create 2. Okay? If I create vectors out of 3 coordinates, if the vectors we create are parallel, those points are going to be on the same line. If we create vectors out of 3 points and they are not parallel, oh, that was not good. So here are our 3 points. If we create 2 vectors and they're not parallel, they're not going to be on the same line. Okay. Are you convinced that that's going to be enough? Okay. It can be, here's 1, 2, 3. This guy is parallel to this guy. Okay. It can be a number of different ways, but as long as we can create 2 vectors that are parallel, we can prove that those 3 lines are collinear. Okay, that's our way of finding slope, essentially, is seeing if the direction is the same, okay, or opposite. Opposite is fine too. So we're going to take these 3 points and we are going to make 2 vectors. What vector would you like to create first? PQ sounds great. Okay, and remember, terminal minus initial. So if we're creating PQ, we're going to have -4 minus -2, 8 minus 7, and 1 minus 4. Yes.
How do you know which one's terminal?
Well, if I named it PQ, Q would be the terminal, P would be the initial. Okay. What's the next vector you'd like to create? QP would not be an option. No. Okay. You need to create 2 vectors using all 3 points. Okay, so vector RQ. Q is the terminal point again, so -4 minus 0. -8 minus 6. And 1 minus 7. Okay, so I want you to look at these vectors. Are these vectors parallel? They are parallel, and we know that because we could take PQ and multiply it by 2 to get RQ, right? Okay, so we know that PQ is parallel to RQ. So P, Q, and R, that's a comma, really big comma, but must be collinear. Okay. I do want a little bit of an explanation. I need you to tell me how you know that they're parallel, and then I need you to tell me since they're parallel, they are got to be collinear. Alright, so I know notes were a little bit longer today than the past 2 days, but you still have 15 minutes to start your homework. which means you should get a good chunk of it done. Vectors, if you remember, vectors are really quick for outcomes, okay? So if your assignment seems like it's longer than normal, they're gonna go quick, okay?
We'll party next hour.
It's not a party, we're doing calculus.
Are you guys gonna be eating the cake?
Maybe eventually.
So I should be in the class. I think Will